Hello. Have you ever wondered what happens when you oxidize different types of alcohols? Well, in this video, I'm going to be breaking it down. Primary, secondary, and tertiary alcohols, what they turn into and why. What is oxidation before we move on? For this particular reaction, I'm going to be defining oxidation as a reaction that increases the number of bonds to oxygen. Now, in alcohol, oxidation can produce aldehydes, ketones, or carboxylic acids, and that would depend on which alcohol we start with. The first example here is a primary alcohol. A primary alcohol, when you oxidize them using a weak oxidizing agent, the product we'll get would be an aldehyde. For those who don't know what a primary alcohol is, when the carbon, this is a carbon, bearing the OH is connected to only one other carbon, then it's primary. So when this primary alcohol undergoes weak oxidation, which means that the reagent is a weak oxidizing agent. Example is PCC, another example is DMP and SWEN oxidizing agent. When any of these weak oxidizing agents reacts with a primary alcohol, the product would simply be an aldehyde. What you would be doing is remove this hydrogen and make this a double bond. And that is an aldehyde. So this same primary alcohol, if it reacts with a strong oxidizing agent instead, example of a strong oxidizing agent would be potassium permanganate, KMnO₄, or chromic acid, which is H2Cr₄O₄. Another example is potassium dichromate, which is K2Cr₂O₄. These are typical examples of strong oxidizing agents. So when this primary alcohol reacts with a strong oxidizing agent, the product would be carboxylic acid. Why does this happen? The first step is going to first oxidize it to an aldehyde. Okay. Now, there is still a hydrogen here, and that hydrogen would further be oxidized to a carboxylic acid. So that changes to OH. Okay. So that is simply how you do it. Now, I'm not showing you the mechanism, but just how you can easily predict the product. Now, let's look at what happens to secondary alcohol. Now, a secondary alcohol, the carbon bearing the OH will be attached to 1, 2 other carbons. That's how you know it's secondary. When a secondary alcohol reacts with both a weak oxidizing agent and a strong oxidizing agent, the product is going to be a ketone. So you simply just, again, remove the hydrogen and turn this to a double bond O. Because of this double bond and the position where it is, there's no hydrogen left on this carbon. And that is why the strong oxidizing agent will give us exactly the same thing. Okay? Because there's no more hydrogen for you to oxidize. The last one we looked at, there was hydrogen after aldehyde was formed. So because it's a strong oxidizing agent, it further oxidized the hydrogen and that became carboxylic acid. But in the case of secondary alcohol, it's not going to happen because once the first oxidation is done, there is no hydrogen on that carbon to be oxidized. Of course, there are hydrogens in other area, but we are talking about the carbon with the OH, okay? Original carbon with the OH. So there's no more hydrogen to oxidize. And what about tertiary alcohols? For tertiary alcohols, the carbon bearing the OH will be attached to 3 other carbons. Okay, that's what makes it tertiary alcohol. Well, tertiary alcohols don't oxidize easily. And that is because there's no hydrogen on the carbon attached to the OH, so oxidation doesn't happen under normal conditions. Now, strong conditions might break the whole molecule, but that's not really oxidation. It will be probably decomposition instead. Okay, so tertiary alcohols do not undergo oxidation. So there will be no product for this one. Okay, and that is how you can predict the product of alcohol oxidation. I hope this video has helped you. Thank you for watching. Do have a wonderful day. Bye.